Yesterday we covered discrete stuff. So what is the difference between this is like let's see, discrete formula, right? Discrete formula is same as continuous stuff, okay? Because concept is same, okay? The difference is like this is about summation and this is about integration, okay? That is the only difference. So yeah, that we have to do. Also, uh, yeah, I think yeah. So bro, like like I yesterday was using my phone as a calculator because obviously those huge calculations definitely calculator wouldn't have done. But phone was also tweaking, like it was shortening the answer yesterday. Like it was crazy. Like yesterday's question was crazy. Like I covered those in shots. Like there was mean given, and we had to find next to probability with that. So that was there, and like bro, like bro, I actually like gone two shades down yesterday, like from like perspiration, bro, heavy perspiration. Like summers are crazy right now. Like bro, I just turned from colored person to pale white in quick second yesterday. Whoa! After break, I actually saw that. That's crazy. So I thought it would sound funny. I know I'm bad at being funny, but yeah, I thought that experience sharing would be funny, but yeah, veins were popping out, man. That's crazy, bro. Like, white veins, bro, like crazy. That's crazy. So much heat right now. This is really weird, bro. Like crazy stuff. And also, I saw that like uh, I'm just diverting from the topic. Sorry, but yeah, season two of ReZero has dropped, bro. Like crazy. Like, bro, I never expected that would happen. And ReZero is like an anime, bro. That's really, like it shows you how life is painful, but still you would watch it even if you don't like it. So yeah, that's how it is. So let's get back to the topic. So, yo, what's up? Three people came to the stream. What's up? Welcome to the stream, man. Welcome to the stream. Thanks for joining, man. For real, appreciate it. Well, come on in the chats, bro. Like we can interact. So yeah, find values of k. So today also we have to find values of k. So yeah. So what is the first formula we are gonna try? Is integration of rx f of x dx is equal to 1. Why? Yo, 10 people, bro. That's crazy. Welcome to the stream, bro. Thanks for coming. Really appreciate it. Well, come up in the chat section and, strike up a conversation. Right. That'll be really cool. So, yeah. Yo, 12 people, bro. That's crazy. That's crazy. For real, man. Come up in the chats, bro. Come up in the chats, man. For real, bro. Like, crazy. This is crazy, bro. Like, 12 people on the stream, bro. So, yeah. First formula we are gonna go with is like total sample thing, right? Like, total sample space stuff. Like, I told you. Like, every probability, like, every possibility, let's say, every possibility if you start favoring, then obviously some of it would occur, right? Let's say I roll a die and I would win, and if any numbers falls, any of the six number falls, obviously there are six numbers, there is no extra number that's gonna spawn randomly. So obviously I'm gonna win whichever like number falls. So if I start favoring every possibility, obviously something surely would fall for my favor, right? Now what happens here is, so that's what you are doing. So this is actually range of f of x, range of your probability function, right? How the, like I told you. So for, wait a second, I would explain this. Range of probability function, and what did I say is function? Function is a rule, okay, which you, in which you put inputs and it changes, okay. Inputs change it, okay. So that's how functions work. So this is your, like, limits decide, this is your limit, okay. Limit decide, like, how much is the sample space you are taking, considered sample space, okay. I hope I'm audible, the audio is coming. Like, limit tells how much, consider sample space, okay. What sample space you are considering, okay. Yo, for the people, what's up, bro? How's the day going? Why not come up in the chat section, bro? Come on, bro. Like, real, bro. Come up in the chat section, man. Yo, 7 people, let's go. So yeah, first we have to use this formula so that we can find k. Okay, you have to find k first. So this is our function, okay. So this is just a, just an excuse for people to make you do integration in the name of probability. So yeah, and obviously the discrete one was like, making you do, like, discrete function was making you like do, statistics. So there is everything injected into probability now. Statistics is there, integration is there, everything is in probability now suddenly. So yeah, so this limit says how much sample space we are considering. So when we are taking limits, oh sorry, I can write this here too. When we are considering sample space, like the function, the whole function where it can reach extent, whole function reaching extent till probability can reach. So what we are doing is actually, we are actually, give starting to favor every possibility, everything that is possible. We are okay with everything. Let's say, your mom takes you to an ice cream shop, and your mom asks that, like, which ice cream do you want, and let's say, you don't want to speak to her that day, like you are so angry and something happened and you don't want to say, but in your mind, if you like every flavor in the shop, then obviously if mom doesn't ask you and just buys you random ice cream, then chances of that ice cream being your favorite would be the highest, because there is no extra ice cream that she can buy for you, because that is the only options in the shop, right? That's the only options in the shop. So there are, like, 100% chance, okay. So what we are talking is, we are just talking about 100% chance, okay. So that is actually one. So this function gives you 100% chance. So this is one, okay. So let's just find it, okay. Let's just find it. Wait a second. Uh, so this is the continuous, random variable like stuff. So let me zoom out. You take screenshot or notes if you want. Okay. Yeah, here we go. So, uh, yeah. Let's just go ahead in the question. Yo, 3 people in the stream. Come on, bro. Let's go. Come on, the chat section, bro. Like, for real, bro. Come up, bro. It'll be fun talking to ya, you know? So, f of x. Our f of x is this. Wait a second. So, what is your range? Your range is always mostly given in the question, okay? Your range, like from where to where your function works. So, we have that in our question. X is greater than 0. So, Anything greater than 0, like x is anything greater than 0. So anything greater than 0, our function works in it. So that is our range. Like range tell where the function can work. So what is x is like what is greater than 0? Obviously infinity. So this is your range, okay? So 0 is the lower limit, infinity is the upper limit. Work function, okay? So functions work in between this for our function. Limit is already given. So let's go for it. K x square e raised to minus x. K x square e raised to minus x. And what is it equal to 1? So equation is complete and there is only one variable we have to find. So yeah, it is kind of okay. We can find it, I guess. We can find it. Maybe. I don't know. Let's go for it. So I have to tell you that integration of x raised to n is equal to uh, x raised to n plus 1 by n plus 1. I told you like integration is antiderivative, so it raises power while derivative reduces power. So that's why integration is the opposite stuff, right? So and also I had to tell you something like integration of wait a second integration of kx is equal to k integration x. So yeah, k goes outside. Like let's say k is a constant. So this is a coefficient because it is multiplied with the variable stuff. Simple. So now what happens is when you integrate this stuff, so this k you just can take it out, take the integration of the variable and just multiply it later on like directly. So that's what we are gonna do. Take k out because variable is gonna do its stuff and the constant job is just getting multiplied. Simple. So 0 to infinity x square into e raised to minus x. Now what we do is uh, integration of like derivative also e raised to x is e raised to x, okay? So integration opposite, so opposite of same thing is also same thing. So integration is just exchanging this equal to side. So it would be same thing because even if this goes here, it is e raised to x, and these exchange places, then it is also e raised to x. So derivative of e raised to x is also e raised to x. Integration of the e raised to x is still e raised to x. No one can break e raised to x. E raised to x is a model. So now, but you have to like look into this that we have two x functions. By the way, this is dx, okay? F of x dx. We have to remember that because this is very important because only this would be integrated like x is only integrated here, others are constant here, okay? Others are constant, okay? So that's what is important. That's why mentioning dx is very important because only this means only x is getting integrated, others are treated as constants. So that's how it works. Now since you see there are two multiplied functions and both are of x and you are integrating both of them together multiplied, now what how can it how can we do that? So that's the concern, right? So I told you once, but I would tell that again too. Wait a second, my marker died. I have to grab another one. So yeah, so integration of u into v is equal to u integration v. So v always integrates and u sometimes divides, okay? U integration of v minus v, sorry, wait a second, integration u, sorry, not u dash, which is derivative of u, du by dx, and another integration of v. Simple stuff. No? Yeah, like crazy stuff, Yeah, that's how it works. Now, you can also remember it in a easier way, let me tell you, which is integration of u by uv equal to uv dash, sorry, wait a second, uv1 minus u dash 1 v dash. v2. So what happens here is this increases and this dash increases, and here also number increases, but this is always smaller than this. Like u's subscript would be smaller than v, and what subscript says, subscript, like v has 2, v has 1, u has 1 here, means integration, okay. And superscript, or like above what we write is like dash, here one dash is there, and that would increase, okay. Superscript, superscript, right. So super means upper, right, top of everyone. So like that you can remember, like superscript, that is derivative, okay, taking derivative, because we took derivative here, right. Now also we have a priority rule in this, like with you can't just randomly take u and v, because that matters. I would tell you how, but let me show you, which is called e8 log inverse c, because what happens is in integration we increase our power, okay, we increase power, but in derivation we reduce power. In derivation we reduce power, integration we raise power, right. But sometimes like let's say our exponential, wait a second, this is algebraic, this is trigonometric, this is exponential. So what difference it makes is when you keep exponential, like this is at the last, so exponential function is never your u, okay. It, you can never take u as like exponentials, because why, this is because if I take derivative of exponential, it would never reduce. So let's say until the derivative becomes 0, this would go on like chain reaction, right. You took this, now when you take this, then you would see that this integration outside again makes this like multiplied like derivative of u. If it is not 0 or 1, then it is here only, and v obviously it is integration, integration raises power. So I have to make this a rule, integration raise power and derivative reduces power. Now what the problem would occur is reduces power. Now what the problem would be is integration raises power, derivative reduces power. So what would happen is, so here this is a chill stuff. No issues right now. But here, even after taking integration and multiplying with a derivative, you still have to take whole integration. If something is that in the derivative term, like it is not 1 or 0 and this is not cancelled out, then there are still two functions multiplied, like, because integration would not vanish away. This only increases power, okay. So if this increases power and this is also intact, then it is again like two functions multiplied, total integration. You have to again do this, and actually you do this sometimes, because this is a chain reaction type stuff. So what this helps is exponential never changes. Even if I put this in v, I double integrate it, still it would never raise power. No change in power. Derivating it is waste. Integrating it is useful, because it doesn't increase. But here it won't reduce. We need reduction. So that's why it's bad. Or else chain reaction, you would be stuck integrating whole day, but won't achieve anything. Like the questions won't be done, because you are just doing integration and still stuff are intact, while others reduce power. with derivative. So I have to explain this. When you take v as exponentials, however you integrate it, it won't increase power. When power gets increased, things get more complicated. Okay, complicated. Let's say okay. So things get complicated when you increase power. Things get complicated. You have to solve more things. But when I keep a derivative here, it derivatives work is reducing, but it won't let it reduce. Like e raised to x would never reduce. It won't do anything. Derivative won't do anything to exponential. No changes. Same always stays the same. Whatever you do, rather bring like multiplication stuff, but nothing would change. Like if there is e raised to 2x or something, chain by chain rule, it would come again and again. So now what would happen is, so e raised to x would never end. It would be there. Now something is integrating, like let's say algebraic or something. So that is obviously increasing power because others change, right? Others change. And if integration power increases, right? So it like these log and all that, log algebraic stuff, then it would keep increasing, bro. Like it would just keep increasing. Log and all these would keep increasing at integration. Its power would keep increasing. It would never end. And since du by dx is not never ending, like there is e raised to x always, it won't change. So that is why this is again double multiplication integration. Now you do it again, this whole formula again, again and again and again. But when you keep this e raised to x, no power increase. Here, algebraic function derivative, it reduces power. Sometimes it becomes 1 or 0. And here there is either one function, like 1 multiplied to anything is only single function. Let's say reduces power and becomes 1. Then 1 into x, anything is x, which is one function. So integration chain breaks. So integration chain breaks. Like this formula is for double like two function multiplied integration. If this is 1 or 0 and this multiplies to this and becomes 0, or this function or one function, so we don't need to apply this, we can directly integrate it. We don't need to like do multiplication integration formula. So this chain won't increase, chain breaks. And we don't want to solve stuff for infinity. We want to like find answers. So that's what it helps, right? Now what I would do is, now also we have to study like chain rule. Yeah, we have to study chain rule. So what I would do is integration of uh wait a second. Yeah. Let's say integration of f of ax. Okay. Now a is a constant. Then what would it be? Like it is inside a function. It is not a multiplied or multiple of function or coefficient of function. No, it is totally integrated inside the function. Like it is part of the function, right? Part of function. So what is it now? Now what happened is, uh, so this is function inside a function, right? Let's say this is a. Okay, let's say this part is a. So f of a is equal to x, and which is, wait a second, this is ax, right? Now f of x, like, do you understand there is function inside function? Okay. Yeah. Oh, sorry. Yeah. I did something wrong. Wait a second. Like, a is equal to ax, which is f of x, and let's say this is, now u is equal to f of a, right? So this is, wait a second, function in function. So how to take integration of this? So what you would do is just do f of ax. Sorry. Take integration of f of x. Okay. Take integration of f of ax, and I hope the audible is audio is clear. I hope so. So f of x ax divided by derivative of ax. Okay. Now why did I do that? Why did I do that? Because in derivative inside function got multiplied, and since integration is opposite to derivative, right? So we do the same thing, but in inside function we divide it. Okay, we divide it. So wait a second for real. So in derivative inside function we multiply derivative of inside function. Let's say derivative of inside function we multiply, but in integration we divide the derivative of inside function, right? So that's how it works. So this is how it works. Okay, so now what I would do is, let's apply our integration rule. uh Wait a second. Yeah, wait a second. Okay, integration of, oh, let's do this. So this is what happens here is, this is outside. Yeah, I told you, take it outside then integrate inside. Okay, took it outside. Now what we would do is, integration of uv is u integration of v. Since we saw lineate and algebraic, we take x, like u, so we are taking this algebraic function as u. So let's multiply this x square, and then integration of v, right? integration of v is Integration of v is this. Okay, integration of v is, integration of e raised to x is e raised to x. So e raised to x is our v, so e raised to, but this is minus x, not x. Okay, this supposed to be e raised to x, but this is minus x. So what I would do is I would take derivative of minus x, okay, and divide it. So this would be divided by minus 1. Why is this? Because let's say minus x. What is minus x? Minus 1 into x. Nothing is there, 1 is there, right? Yeah, let's just wait a second. My camera focus is gone, I guess. Yeah. So, let's see. X is there, nothing is there means x into 1, because x into 1 is always x. Multiplicative identity rule. Identity rule. Okay. Anything multiplied by 1 is itself. So x means x into 1. Now there is something minus stuff. So obviously it is minus 1 into x. So minus 1 is there, so why not bring 1 into it? Okay. So now minus 1 into x. What do you do in derivative is, derivative of d by dx of k f of x, which I told you. Now, like in integration 2, we do the same thing in derivative. We take the k out, multiply after derivating the f of x, like the function we want to take derivative of. We just multiply k to it, right? Now, what we do here is I would take the 1 out, then take derivative of. Wait a second. Why to ruin it here? I took 1 out, took derivative of x. Now it is same stuff in numerator denominator. Let's cut it, or else I can show you how it works. And let's just show you how it works. Wait a second. I would like to search for my marker because I'm not finding it. Okay. I guess I'm not gonna get my marker now. Okay, let's try another marker. Yeah, okay. So, where was I? Yeah, d by dx of x raised to n is equal to nx raised to n minus 1. I told you. So, what happened here is this, like here it divided, the exponential power divided, here exponential power becomes coefficient multiplied, and here it is raised to n plus 1, it is raised to n minus 1. So, power reduces. Whatever is power, it is n, okay? So now in dx by dx, what is in power? Let's say dx by dx. So what is in power here? So nothing is there means 1, because anything raised to 1 is that itself, right? Because it tells times it multiplied itself, right? How many times it multiplied to itself? So x raised to 1 is x itself, right? So why not write it x is raised to 1? So now raised to thing here is 1. Here raised to thing is here n. So what do we do in that n? That n we only changed. So how it changed? I made it coefficient, then reduced its power. So I make it its coefficient here and reduce its power, and anything raised to, so wait a second, minus 1 into 1. So what happened here is minus into plus is minus. So opposite signs become minus. Minus 1 into plus 1. Oh, sorry, minus 1 into 1 is minus 1. So x raised to so this derivative term goes away. So x raised to 0, because 1 minus 1 is 0, and anything raised to 0 is 1, and so 1 into 1 into minus 1 is minus 1. Simple stuff. So that's why denominator, and we had to divide this. Where was it? So we divide the derivative term. So I divided it. By the way, it can come in numerator, no big deal. Now we have to deal with this minus integration du by dx. Du by dx. So what is derivative of x? Okay, derivative of x square by dx. Let's go. And integration of e raised to x, and this is gonna be kind of troublesome, right? It is gonna be. I'll show you how. Now let's do this. Let's do d by dx separately. Derivative of x square by x. What is here in power? 2. So d by dx, x raised to n power is n. So here we change n. So it is nx raised to n minus 1, right? Now what we do here is, this is the power here 2. 2 is n here. So what did we do here? Nx raised to n minus 1. We made this power n as coefficient and reduced its power, and we make this 2 as coefficient and reduce its power by 1. 2 minus 1 is 1. 2 would be there, and this is 1. 2 minus 1 is 1. Now what did I tell you somewhere? Anything raised to 1 is itself, like and multiplying anything to 1. Ha ha ha. So 2x, right? 2x. So integration of e raised to x, I told you, stays same. E raised to x, that's the benefit of Leibniz rule. That's why Leibniz rule exists. Now k into minus x square e raised to minus x. Uh, I can bring that to numerator. It is the same thing divided. Like sign getting multiplied and divided, it is same thing. Like anything divided by 1 is also 1 because no division is there. Take while we take multiples of it. Okay, we take multiples of it, that there is no division, so obviously x by 1 equal to 1, right? Wait a second, what is this symbol? I don't know. So x by 1 equal to 1. So minus sign can go up. Now what I do here is minus integration of this 2x stuff here, divide dx stuff, 2x. What do we have here is integration of e raised to x. I told you it doesn't change. E raised to x, e raised to x. Oh, by the way, this is minus x. So what happened to e raised to minus x integration? I told you. Did I tell you? Mm, yeah, we did u integration v. So we did u integration here, and this was the answer of the integration of e raised to minus x, e raised to minus x by 1. So I showed that, and also I showed this to you. So this is how it went, right? So yeah, so we just take that answer. So it would be divided by minus 1, right? E raised to minus x here, e raised to minus x by minus 1 it was, and I brought that minus here. This would be e raised to minus x minus brought here. So what I told you is minus into minus is equal to plus. Same sign multiplied gives plus. So this I'm since this is multiplied to all this. So now what I would do is here. So this minus sign which came out, it can get multiplied to this and becomes plus. And we have fun. Now I have to erase all this. So uh, note this all down. I would zoom it out. Take screenshot, take notes, whatever you like. So I can skip to the next part. Okay. Wait a second. So yeah, so that's gonna be a problem. But yeah, I guess I can't search for it now, I guess. So yeah. So yeah, we are gonna go now because I'll go ahead because this integration still has two functions as you can see, x and e raised to x, e raised to minus x. So I told you the chain I explained. Now again, this is two like because here also there are two functions. Only this becomes one function because du dx gets cancelled or something, read by getting reduced power, or else it is always just a chain of integration. So it now chain of integration because there is still x surviving here. So that's why the more the power of the variables, more complicated things become. So did you take screenshots? Did you take screenshot and notes? Did you take it? Yo, what's up? Hello, welcome. Hello, mic testing. So okay, so I have to raise this. Why not? I have to raise this. Okay. What should I erase? What part should I erase? Wait a second. I can erase this, I guess. Also, I should erase this part, I guess, maybe. Yeah, I can erase this part. I can erase this part, right? Now what I would do is, I would move ahead I don't know why markers don't work. Yeah, whatever. So now what we have here is, by the way, I can take this 2 out because I told integration of coefficient into function of x is taking out a constant coefficient and integrating with f of x. F of x, bro. F of x. So I can like take the constant or coefficient out and integrate the function, then just directly multiply it. So 2 goes out. K minus x square, bro. This so tiny question. It elongated so much. Now this is going crazy. Thus 2 comes out because this is the constant of multiplied, so I can just take it out, then multiply after doing the integration of this function. So I can integrate this function and then add it. Okay. Integration. Wait a second, bro. Like I guess I have to stick to that green marker. But it is not that visible, bro. That's the problem. At least on the board, it is not visible. I don't know what's going on the screen. So yeah, uh, minus x square e raised to minus x plus 2 integration. Then I put this f of x k integration. I put out k. I put out constant. Then do integration of the variable. Then multiply it afterwards. X raised to minus. Oh, sorry. This is e raised to minus x. Now what I would do is Liet rule. Wait a second. Now I would rub this too because I don't need this, right? I just copied it up here. I don't need this. I would just rub it. Simple stuff. Woohoo! Clean, clean. Not that clean, but yeah, kind of clean, isn't it? Now what I would do is, uh, integration of. Let's just do this separately. Integration of x e raised to minus x is equal to. Now we are just doing chain reaction, right? Now we have to use this formula: integration u v equal to u integration v minus the integration derivative u by integration v. So u is x, x here, integration of v is to minus x, and this is minus integration derivative of u is this dx by dx. Now here integration of v e raised to minus x. Now this elongated so much, this stretched so much. So yeah, I also told you dx by dx is always 1. Wait a second. Okay, this is a minus 1, but yeah, you got the essence, right? If I remove this minus sign here and this minus sign here, obviously this is 1 into x, no, x raised to 0. X raised to 0 is 1. And 1 into 1 is 1. Simple stuff, right? So let's go for it. This is supposed to be 1. Now e raised to minus x integration, definitely e raised to minus x. No changes, but I also told you that. Wait a second. Okay, let's just do this d raised to d of x by something. See, dx by dx is equal to. So there is nothing, so 1 is there because x raised to 1 is x only. So this x raised to 1 is there, and so a raised to thing is 1 here, x raised to 1, and here x raised to n, raised to thing is n here. Wait a second, where is it? Yeah, raised to thing is n here. So n changes, so how it sorry, the derivative. So raised to thing is n here, x raised to n, and n only changes here. So we would also change n here. So what changes it happens in n here? So n becomes raised to becomes coefficient and reduces itself by 1. So here we have 1, make it coefficient, and x raised to n minus 1, we reduce this power by 1. 1 minus 1 is 1 into x raised to 0. 1 minus 1 is 0, right? Now, what happens here is x raised to 0 equal to 1, so this is 1 into 1 equal to 1, and that's how we got this, right? Simple stuff. Now, my integration of e raised to x. Integration of e raised to minus x equal to. First thing is, integration of e raised to x is integration of e raised to x. Wait a second, let me show you. Integration of f of x, because this is chain function, because this is function of c. There are two functions, e raised to something, like e raised to, let's say, a function, and let's say a is equal to minus x here. So this is also a function, this is also a function, and we are taking integration of this function. Now inside function, what you do is integrate the outer function. So outer function is integrated. Integrate e raised to minus x out function. Then divide this by derivative of inside function dx. Inside function. This is inside function, right? So now when I derivative this and divide this by derivative, inside function. Now what is minus x derivative? Yeah, minus x derivative is this, right? Where it is? Wait a second. This is minus 1 into something 1 dx. So this is minus x, right? So this is minus 1. So now what happens is integration of e raised to minus x is e raised to x. Just take the integration, like here it is. Integration of e raised to x is e raised to x. Here it is minus x. Keep this as it is. Divided by d of minus x by dx is here. D of minus I took outside because of this rule. D into derivative of constant into function is constant taken out, then function you take derivative and multiply constant later on. So I took minus 1 outside, like it was minus 1, because see, x into 1 is x, which is multiplication identity, so x is x into 1, nothing changes. So minus x, so minus is there, so minus, why not take 1, and 1 minus 1 into x. So minus 1 I took out, then take derivative of x is x stuff, dx by dx. Then dx by dx, we know it is 1, right? So just later on multiply this minus with it, right? What I did here, 1x naught minus this. So this is how it happened. So this is e raised to minus x by minus 1. So now what I would do it is here. So we have 2 times integration this stuff, right? So now what integration x e raised to minus x would look like is x, same stuff, no integration stuff, and e raised to minus x integration, we found it minus e raised to minus x. So what I would do is I would put the minus here, e raised to minus x, because denominator this stuff, anything divided by 1, I told you here, yeah, anything divided by 1 is 1, because no division and we take multiples of it. So what happened here is e raised to minus x by 1, so it is e raised to x, nothing changes. What is this minus? So I can take it upside. So yeah, minus x e raised to minus x minus 1, wait a second, integration of 1 into e raised to minus x is actually e raised to minus x, I found it, is minus e raised to minus x minus e raised to minus x. Now okay, wait a second. Yo, one person came to the stream. Welcome to the stream, man. Thanks for coming. What's up? How's your day going? Why not come up in the chat section, bro? Like, we can yap, bro. Like, for real. What is up? What is up, bro? How are ya? How's your day going, bro? Like, how's your day going? Okay, he left. Have a nice day. See ya. I guess he left. So yeah, what do we do here is I take this minus and I multiply it here. Because what did I say? Integration of some constant. This is minus 1. I told you here. This is minus 1. So integration of minus 1 into this. So what did I tell you? What did I tell you? Integration of constant into f of x equal to constant. Take it out. Take integration of f of x. Then just multiply it. I am taking this minus sign out, as it is a constant, and minus into minus is plus. I told you minus into minus is plus. So minus into minus is plus. Took this minus. Now e raised to minus x integration. What I told you, e raised to minus x integration is e raised to minus minus e raised to minus x. Let's go. Minus integration e raised to minus x. So integration minus x became this. And since this is only one single function, this was became 1. 1 into anything is that itself. Told you, right? Okay. X into 1 equal to x. Anything multiplied by 1 is that itself. So anything multiplied to 1 is that itself. So what did I do here is I just multiplied 1 into integration e raised to x, right? So wait a second. How many times did I integrate this? Oh yeah, I integrated it. Nah, bro. I integrated it 2 times. Yes. So now what happens is, uh, so I did what I did is this became 1. So it reduced 1 into this stuff is itself. So integration minus e raised to x, integration minus e raised to x is minus e raised to minus x. I took it once, then I multiplied it out self, and it this became plus. This was minus. This became plus. Now this was double derivative, so I took another derivative of this, because now it is a single function. I can just simply integrate it rather than using this UV formula. Yo, thanks for likes. Yo, bro, thank you for the likes. So, thank you very much. Why not come up in the chats, bro? Like, come up in the chats. Thank you very much for the likes. Appreciate it. Thanks for the support. Suman Das NZ9DJ says, crying emoji and raise hands up. Thank you for the like. Thank you very much. Appreciate it. Thanks for your kind support. You are a very kind person. Thank you very much. Thanks for your support. Appreciate it. Suman Das NZ9DJ says, in Rio. In Rio? Like, are you saying you are in Brazil? Rio de Janeiro or some football stuff you are doing? Or are you playing Angry Birds Rio? But Angry Birds Rio, I guess that game is not available. That is only available for nostalgia. But yeah. So what is in Rio? Oh, wait a second. Oh, okay. Okay, I got it. Okay. Okay. Okay, wait a second. Sorry, I have to remove this. Okay. Yo, what's up? Sumandas, what's up? Rio, what's up? So why are you crying? Like, did I do something? By the way, I'm really sorry. Okay. I, for some reasons I deleted that message. All good. What about you? As you can see, I'm just diving into this stuff, something which I even don't understand to a point. Maybe I'm dying from inside. What I can say, life is unfair, as Supreme Leader says. So, what about you? How's your day going? Yeah, just going on. Gambate kudasai yo. You also. Gambate kudasai, senpai. Go on your journey ahead. Best of luck. Have a good day. And maybe revise your. I know you are a genius, but maybe revise this or something. You might not even need this, but yeah, why not? Just have fun revising, you know. So yeah, so integration of e raised to minus x. Okay, so it is I took double integration of this. Now yeah, I took integration of this once. Now this became a single function because one multiplied by this e raised to x, it became itself like it is a same thing, but this is one stuff, so you don't have to take trouble to integrate it like, you know, like this huge, humongous, horrendous formula. You don't have to use that. You just have to simply integrate it, and simply I integrated it and kept it for you, which is e raised to minus x is e raised to minus x minus e raised to minus x. So yeah, minus e raised to minus x. So what I do is, so this is in multiplication, this plus into minus is e raised to minus x. Okay, plus into minus is minus. I told you. So what would happen here is minus x e raised to minus x plus sorry, this is minus e raised to minus x, which would be, let's take minus common outside, and by the way, it can multiply later in bracket, like inside the brackets multiply to both things, so it would be again the same stuff. So I didn't change anything, I just wrote it like I can solve it better. So also I take e raised to minus x common outside. Okay, I have to do it again, minus e raised to minus x common outside, and I take x minus 1. So what I do here is x minus 1. Okay, so mm, wait a second. When I do x minus 1, yeah, what I did is, if I take minus from here, what is left? Minus into plus is minus, so I took out minus, so it was minus into plus, so plus is only left. Here also same, plus is only left. Now I took e from both of them, e is out. What remains here? X is only left here. This was actually e raised to x is e raised to minus x is e raised to minus x into 1, because anything you multiply to itself is that only. So yeah, e raised to minus x into 1 is e raised to minus x itself. So I took e raised to minus x, so obviously 1 is only remaining. So that's how things go on. So now I guess we simplified this, and this humongous stuff we have to put here in this. Okay, now I would put this here. So yeah, let's just put this is 2, and yeah, just take a bracket, uh, minus e raised to minus x minus 1, x minus 1. Yeah, so now it kind of looks less scary. So okay. So now what I would do here is, now I would put limits. So I have found this function. So this is supposed to be 1, by the way. This is supposed to be 1, okay? Because integration of this range stuff is 1. So I have to zoom out so that you take screenshot and notes, and I would rub all this. Okay. So take screenshot, take notes or whatever, and take screenshot, take notes, and what I would do here is, did you take it? Wait a second. Sorry, I didn't keep it much longer. Here it is. Now what we do is, I would just keep this part, and I would have to put limits, right? Okay. Oh no, I have to erase all this formula. I'm so lazy writing all this. and I have to write it again. Oh, my laziness. My laziness would lose. I would lose my laziness. Whatever. Yeah, so erasing all this, erasing. Okay. Now what I have to do is. Yeah, so now let's go. So now what I would do is equal to k. Now I have to put limits, right? How do we put limits? Since, wait a second, this is about dx, so you have to put these limits in x, substitute in x. Okay, you have to substitute all this in x, and it is always upper limit minus lower limit. Okay, this is lower, this is upper, as you can see, down up down up down up. Okay, that's how it works. And first thing we write it here, like first was 0, then x, so x infinity was above. Okay, like this x, this shows x, this is supposed to be greater than 0, greater than 0, so it not specified how greater. Take till infinity, done. Simple stuff. Now what I would do here is k into so I have to put this, okay, in infinity and all. So I don't know how I would put this, but yeah, let's try this. X square is infinity square, gonna still be infinity, into e raised to minus x, okay, multiplied by e raised to minus infinity plus 2. I guess anything raised to infinity is supposed to be infinity, but yeah, well, let's do this. 2, so this 2 would multiply inside both. But does that even make sense? Because everything is gonna be infinity. E raised to minus infinity and wait a second. Okay, into infinity minus 1. Why there is so much infinity? I don't understand. But yeah, why not? Let's have fun. And yeah, I also forgot about like substituting 0. So my wherever there is infinity or x, just put 0. Now, so this would be, whole stuff would be minus from this. Okay, because this is like integration is finding area, and this end is up, this is down, so this area is obviously up minus down difference. Simple, right? Up minus down, so this is the area. Minus 0, e raised to minus 0, so 0 square, okay, minus 0 square plus, sorry, multiplied by e raised to minus 0 plus, okay. So wait a second, I told you, right, anything raised to 0 is 1. Simple. E raised to minus 0, 1. Minus 0 square, wait a second, this was minus 0, yeah, so 0, right, 0 plus 0 into 1 plus 2 into e raised to 0 is 1. So wait a second, multiplied, 0 minus is 1, minus 1. So this is supposed to be 0 into 1 is 0 into 1 minus 1. Okay, minus 2. This is supposed to be minus 2. Okay, this is supposed to be minus 2. Let's put minus 2 here. And now we have to solve this. Infinity square is infinity, infinity into e raised to infinity, still infinity, infinity plus 2 into e raised to infinity, still infinity. Wait a second, minus infinity it should be. I don't know. Wait a second, wait a second. Yeah, 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 we can do this. Minus infinity square should be infinity because, this is a mod function. Like, let's see, minus infinity into minus infinity. Yeah, infinity multiplied no makes no sense, but this minus into minus obviously is plus, right? So square, like infinity into square, this square tells how many times it multiplies itself, right? So now what happened is minus into minus is plus. Yo, so minus into minus is plus, right? So this would be plus, like square function is positive, and this is something like my e raised to minus infinity. So divided by infinity plus 2, infinity minus 1 is infinity. Now this is 2 into e raised to minus infinity, so 2 into e raised to minus infinity means minus infinity. So if I put minus a here, so minus represents, so this is multiply itself, so opposite of it, okay. Power says how many times it multiplies itself. So when I put minus here, it does opposite and shows it's how many times it divides itself, okay. So minus shows opposite of this. Like this is the purpose of raised to is times multiply itself. So when I put minus here, it does opposite. Like it tells how many times it divide itself. So I have some e raised to minus infinity. We don't know what it is, but it is in division. Now infinity minus one is supposed to be infinity. Come on, like from a sea you drink a drop of water. Like what do you think? Whole sea would just evaporate by your superpower mouth or what? No, obviously not, dude. So this is supposed to be 1 because same thing divided, same divide, cancel to 1 as it is their factor. Simple stuff, right? Now this is also 1. Uh, I told you anything into 1 is itself. So this is 2 into 1 is 2 plus 1 is 3 is equal to 3 minus 2. So 2, like this is 1, this is plus 2 into 1 is 2, this is 1, 2 plus 1 is 3 minus equal to 1. Done. Yoo-hoo! Let's go. What is up, yo? Wait a second. Also I have to multiply k. I have to multiply k to this too. This whole mess. I have to multiply k to this whole mess. So k into 1 actually, this is k into 1. And also, why were we finding this? Because it is equal to 1. So it was gonna take our stress away. Equal to 1. So k into 1 is 1. I told you anything multiplied by 1 is 1. So k is 1. Yay! We did this! Yay! Okay. So now this is something that we found out. Now I would zoom out, take screenshot or notes. I'll take a tiny break and see you soon. Okay? Before doing next question. Bye! Thanks for coming. Like, subscribe. See you next time. Bye. Yo, what's up? Yo. What's up? I hope you took screenshot and notes, bro. For real, bro. Come on, bro. Let's go. Bye.